Okay, so last time we introduced the periodical table, and we also introduced the atomic properties. And basically, we know the matter can be element or compound. Okay. So atomic properties is about like the properties of elements. And so here in this chapter we will introduce the chemical compounds. Okay. So for the compounds, basically it should include more than two kinds of atoms. So in this chapter, we will learn the chemical formulas. Okay, now we are in class, okay? Okay, so here you can discuss after the. Okay, so in this chapter, we will learn the chemical formulas, and also we will learn the formation of covalent bond, and the formation of ionic bond, and also elemental analysis to determine the molecules of unknown matters. Okay, so we know we can use the chemical formulas to describe the compounds. Basically, for example, for the compound it may have two atoms. It's called a diatomic compound. Like this, right? Okay, and also it may have three atoms. So it's called triatomic compounds. And more than three, we call them polyatomic compounds. So we can use different ways to show there are structures. So structures. For example, for this, basically, these are organic compounds. We can use these kinds of structure. We can just use these kind of models to show their structures, and also like this. Okay. So here we can see basically each one has a formula. We can use a formula to describe their structure. So this means in one molecule, we can see the numbers of different atoms. Okay. Now the question is, what makes the formation of a molecule? So we know the atoms in molecules are holding together by strong interactions. So this is called chemical bonds. So if the interactions between neutral atoms in a molecule is called a covalent bond. Between neutral atoms, so this means basically there are no electron transfer between the atoms. So we call the covalent bond. So they form the covalent compounds, like hydrogen, right? And the many gases, all of them are like covalent compounds. And the interactions between charged elements, we also call ions, result in different kinds of chemical bond. So we call them anion bond. So this kind of compounds, we call them anion compound. So if in anion compound, the electron the electron should be transferred from one atom to another atom. So for the atom, losing the electrons, so it will show it lose electrons, so plus charge. If the atom gets the electron, so it will be negative charge. Okay, so this kind of compound is called ideal compound, like sodium chloride. So sodium chloride in this compound, which atom lose electron? Sodium chloride. Yes, sodium, right? Yeah, sodium lose one. You lose one to chloride. So sodium is plus one charge, and chloride is minus one charge. But we know in this hydrogen or CH4, so no electrons are transferred between the atoms. So both of them are neutral. Okay. Okay. So basically, for neutron compound or covalent compounds, we can use like a molecule, right? A molecule to describe the structure of the compounds, like an oxygen, right? So in this structure, so two oxygen combine together, right, to form a molecule. We call it a molecule, right? And this is water. So this is oxygen, hydrogen. So they are stay together to form a molecule. But in ionic compound, like sodium chloride, this is the structure of sodium chloride. So of course this is it seems like this, but we can use it this way to describe the structure. So in here, so in this structure, you can't find a part like it's a molecule, right? You can't find a part because in this case we can see this is one molecule. But here, where is the molecule? You can't find it, right? So basically, in sodium chloride, the molecule doesn't exist. Okay. But if one counted the number of sodium ions and the number of chloride ions in a given volume, we would find that the ratio of sodium to chloride is 1:1. It's always 1:1. So basically, we can use like NaCl to represent its formula. So basically, this formula also is called chemical formula. Okay. So this formula it has formula, but you can't find its molecule. But we're still using this way to describe this sodium chloride. Okay. So now another question is, what's the nature of chemical bonds? So basically, chemical bonds results from strong electrostatic interactions between two atoms. So what is electrostatic interactions? So these interactions you can also like force. Okay. So this exists between two parts with different charges. Okay. If they have different charges, they will attract each other. So this force is called electrostatic interactions. We will introduce more about these interactions later. So basically, so for covalent bonds, they result from a strong interaction between neutral atoms. Each atom donates an electron, resulting in a pair of electrons that are shared between the two atoms. So for example, hydrogen. So basically, hydrogen, each one provides one electron to each other. So they share these two electrons. So this means these two hydrogen atoms, they can stay together to form the H2 molecule. So they share the electrons. So they form H2 molecule. Okay, here we show the formation of the covalent bond. So the covalent bond, we know covalent bond means the two atoms or more atoms, they share electrons to form covalent bond. So how to form the covalent bond? So here this picture to show the process of the formation of the covalent bond. So the x-axis is distance. Is the distance between the two atoms. You can see this is like hydrogen. Okay, this is one hydrogen atom. This is another hydrogen atom. The x-axis is distance. The y-axis is potential energy. It's like energy. Okay, so energy means if the two hydrogen system has low energy, this means they are stable. Okay, if they have higher energy, so this means they are not stable. So basically, for example, if they are spread very far away, so their energy like zero. Okay, like zero. So when they are far away from far apart from each other, they don't feel any interaction. If the distance is like this, okay, the distance, they don't feel any interactions. So and their energy like zero, okay. So when they close, okay, and they can feel each other, the presence of the other, and the energy will decrease. And when the distance is like this, here is 35 pm. It's like this, so they have lost energy. Okay, so in this position, when the distance is like this, so we say they form the covalent bond. Okay. So and the electron, because they are so close, so they can share the electron from another one. Okay. This means just share each other's electron, and there are two electrons between them, so both of them share these two electrons. So this means they form covalent bond. Okay, so once the bond has been formed, the two electrons are shared by both hydrogen atoms. So here we can see the formation of the covalent bond. And maybe you can say if they continue to reduce the distance, so the energy will increase faster. So this means this is also unstable, right? So basically, they just like stay with this distance. Stay with this distance. Okay? So here to show the forces between the two hydrogen atoms. So this here also show the formation of a covalent bond. So basically, we know. Okay. So we know the opposite charges attract each other. So this is also called Group interactions. For example, this is one hydrogen atom. This is another hydrogen atom. So in one atom, it has nucleus, right? The nucleus has plus charge, okay? And the electron has negative charge. And for this one, plus charge, negative charge. So between the electron and the nucleus, so they attract each other, right? And this nucleus also attract the electron of this hydrogen. But between the nucleus, they repel each other, right? And for between these two electrons, they also repel each other. So you can see between these two atoms, there are two kinds of forces. One is attraction, right? One is repulsion. Repel each other, right? So when they are apart from each other, far away, so the attraction force is bigger than the repulsion force. Okay, so they can be close. When these two forces are equal, so they will stable. They will stay to form the covalent bond. Okay. And of course, if they close again, so the repulsion will much strong than the attraction. So it will be unstable, right? So just when these two forces are equal, so the energy is low, is lost by. Okay? So in here we can say when the covalent bond formed, just when these two forces are equal. Okay? So when these two forces cancel out, they are equal, right? So to form a covalent bond. So at this length, where the potential energy is at a minimum, Okay? So this is why the covalent bond can be formed between two atoms. Okay? And we introduced before that, when an atom gets electron, its energy will decrease, right? When it gets energy. When it gets electron, it will release energy, right? Do you remember? And then when it loses electron, they should get some energy. Okay. So this means, for example, when this atom show the electron of from another atom. So it looks like it get electron. It get electron from another atom. So it will release energy. Okay. So the energy released is this from here to here. The energy decrease. It's energy decrease. So this means they will release energy. Release energy. When they release energy, so they become more stable. More stable. Okay? So this is why when two hydrogen atoms form H2 gas, they will release energy. They will like release heat, right? Okay. So here also to show the some properties of the covalent bond. So basically, the distance between two bonded atoms and their minimum potential energy is we call the bond length. Bond length. Okay. And in forming a covalent bond, the hydrogen atoms release energy. And of course, if they from this state to this state, they will release energy. But we also can separate them, right? Separate them, this means they change from this state to this state. Okay. So how to do? How to change this state to this state? How to change this state to this state? So from A to C, from A to C, it will release energy, and from A to C, it will release energy. If from C to A, how to do? Yes, we should provide energy, right? If we provide more energy, so it can change it from C to B, C to A. From C to A. So when we provide energy, so the hydrogen bond can be broke, okay, and change it to A, So this energy we call the bond energy. So bond energy is the energy required to break a chemical bond and form a mutual attracted atoms. Okay. Okay. So here also to show the bond length and the stability, and of course, if this energy is high, so this means they release more energy, or they need required more energy to be broken. So this means the bond is strong. Okay, bond is strong, and they are stable. Okay, here is the bond energies and the bond length. So from here we can say, basically, if the bond length is short, okay, it's short, so they have high bond energy. So if the bond length is small, so this means they are close. They are close each other, more close each other. Okay, so then you need to provide more energy to break the bond, okay? And for example, for this guy, they have long bond length, so they have low bond energy. So this means they are easy to be broken. Okay. So just now we introduced the formation of covalent bond. Now this picture to show the formation of ionic bond. So ionic bond, basically, for example, in this case, one is positive charge, another is negative charge, and the same at this distance, the energy. The y-axis is potential energy. So the energy they have low minimum energy. So in this distance, they are stable. Okay. So basically, the two atoms are attracted to each other through covalent interactions. So resulting ionic bond. Okay. And of course, in ionic bond, both of them are separated. They don't show electrons, right? They don't show electrons. Just one electron is transferred from one to another. Okay. So how are chemical formulas determined? Now we know basically the chemical compound. There are two kinds of chemical compound. One is covalent compound, another is ionic compound. So how to determine their formulas? So here we introduce the elemental analysis. Basically, in chemistry, it's called analytical chemistry. So we know in chemistry there are like four big divisions, like inorganic chemistry, right? And organic chemistry, and analytical chemistry, and another physical chemistry. Okay.
Which one is the most difficult?
Which one is most? With physical chemistry, because for physical chemistry you must do a lot of very complicated calculations, and many theories is inside. So it's the most difficult. Okay, so for elemental analysis, so it's about the determination of the relative amount of elements in a compound. This means we need for a compound, for a unknown compound, we need to determine its formula. But before we determine its formula, here is another formula. It's called empirical formula. So what is empirical formula? So we know chemical formula, right? For example, this is chemical formula, right? But what is empirical formula? So empirical formula is the simplest possible formula, and indicates the relative amounts of constituent elements. Constituent. Sometimes constituent. Okay, thank you. Yeah, I can learn some English from you, okay? And if you want, you also learn some Chinese from me. So maybe in the first year, you want the Chinese teacher to speak Chinese You have the class, right? Okay. Anyway, so for example, the molecular formula of hydrogen peroxide is H2O2. So this is, we know it is chemical formula. It's also like one molecule, right? One molecule like this. So, but its empirical formula is HO. Okay, now from this sample, you can see what is empirical formula, right? So empirical formula is like the simplest possible formula. Okay, but of course here 2 we can change like 1 1, right? Okay, and of course the empirical and the chemical formula can be the same like water. So water is chemical formula like this, but its empirical formula is also the same. Okay, for ionic compounds, of course, the empirical formula is the same as chemical formula. Okay. So now we know what is empirical formula. Why we needed to know the empirical formula? Because when we determine the formula of an unknown compound, we can determine its empirical formula firstly. Okay? So for example, here's the question. An oxide of nitrogen is analyzed and found to be, you guys put this online, right? So someone maybe, in the world, they can watch this video.
They don't see your face.
Oh, this teacher is a funny guy.
Funny guy.
Yeah, he has a lot of funny students. Students are very funny. Well, I don't care. Because they don't know who I am. Yeah. Okay, and found to contain 25.9% of nitrogen and 74.1% of oxygen. Now we know. So basically, the question is like the mass percent. Okay, the mass percent. So what's the empirical formula of the compound? So here is the answer. So basically, this is the mass percent, right? So basically, we can like just give like 100 gram of compound. So if 100 gram, so of course nitrogen is 25.9 gram, right? So we're just using its mass. So this is way to divided by this is what is. What is 40.01, like 14, right? Gram per mole. Molar mass, right? Yeah, just using the mass divided by the molar mass. So what we can get? The Morse number, right? The Morse number. So in this compound, the Morse number of oxygen is 1.85, and of course oxygen we can use the mass divided by its molar mass, right? Yes. So the ratio of oxygen nitrogen just using this number divided by this number, you can get this number, 2.5 to 1. So must be the whole numbers. So it should be N2O5. Because the numbers should be integer. So you can't like write N1 0.02.5. Yeah, question.
So you don't round off that. How can I never make up the
Yeah, so you must using the whole numbers. So the simplest molecule, simplest formula should be like this. But of course, so and definitely is chemical formula. Definitely is this one. This is like a empirical formula, right?
Yeah.
So what is the chemical formula? It's only this one. Can you give me another example? For the chemical formula from this. This is the empirical formula, right? Another one. Another chemical formula is also can be like this. Is empirical formula can be this. Another one. N4
oxygen.
O10, yes. N4 O10. This is a compound, right? And its empirical formula can also be seen. And also you can time 2, time 3, time 4. All these compounds, they have the same empirical formula. It's like this, right? So this means if we want to determine a chemical formula, we should know more. We should get more information about these compounds. We can't only from the empirical formula. But sometimes the empirical formula is the same as the chemical, but sometimes maybe they are not. Okay, so that's all for short break.